So dear student, we have discussed also in our previous lecture about the plasma arc igniter. What do you think what the term plasma arc igniter mean? Dear student, please note that plasma arc igniter is a device which is used to ignite those materials which have very high melting points. So basically plasma arc igniter is a device which have a plasma, and the temperature of plasma is very high, and due to a very high temperature of that plasma, when it interacts with a material having a high melting point, those material get evaporated by the plasma which is produced by plasma or igniter. You know, dear student, that refractory metals like zirconium, etc., they have very high melting point. So it is very difficult to evaporate those materials, or it is very difficult to melt those materials. So in order to melt material having a high melting point, we need plasma arc igniter. Dear student, please note that plasma arc igniter is a very diverse machine. It is a very diverse instrument. Plasma arc igniter is used for arc welding purposes. It is a very essential component of one of the very popular technique known as Cathodic arc deposition. So with plasma arc igniter instrument, we can produce a welded material, and we can also produce thin films. Okay. So dear student, plasma arc igniter is a machine. It is an instrument which utilizes the compressed air or compressed gases. Okay, plasma arc igniter utilize the compressed air and or compressed gases. These include nitrogen, etc., and these gases are ionized and plasma is created. Typically, the gas are fed through the back of the machine, go into the system, and when they contact with electrode functional at high potential, they get ionized and create too much pressure. As soon as these gases build too much pressure and ionize, they are pushed out as a stream or a column of highly energetic pure plasma. And at the finest point, plasma temperature is extremely high, which create an cathodic arcing. So let's explain this in simple word. How the plasma arc igniter works. Basically, dear student, plasma arc igniter has a complex compressed gases. Okay, so the gases are incorporated in plasma arc igniter system through outside of the plasma arc igniter chamber. Okay, they are introduced, they are fed from outside inside the plasma arc igniter instrument. The plasma arc igniter instrument has electrodes. These electrodes are functional at high potential. So high potential is applied across the electrodes which are present in plasma arc igniter instrument, and at the same time gases which are very compressed are incorporated inside the plasma arc instrument. Okay, so when the gases are incorporated and they reach onto the surface of the electrodes which are present inside the plasma arc igniter instrument, the potential of the electrode is very high. Due to very high potential, the compressed gases get ionized inside the plasma arc igniter system. So the compressed gases are converted into their plasmas. This means that when the compressed gases interact with electrodes inside the plasma arc igniter system, those compressed gases are converted into electrons, protons, and neutrals or excited atoms. Okay, now the plasma arc igniting system has a huge range of ionized gases inside the igniter system. These gases are channelized through a very small hole which is known as an orifice. Okay, and when they pass through a very small region or very small point, the plasma appear as a stream or a column, okay, having a very high pressure and temperature. So when they pass through orifice which is very a small hole or a very small part of the instrument, and when they pass through that part, the pressure and the temperature of the plasma reach up to its maximum, up to thousands degrees of centigrade, and in this way the plasma, a stream of plasma is basically taken out from the instrument, which is then used in cathodic arc deposition and as well as plasma arc welding, etc. Okay, so dear student, in a simple word, plasma arc igniter use very high potential electrodes, and in that system the gas which is compressed is incorporated, and when those gas interact with the electrode inside the plasma arc igniter system, they result into an ionization and they form a plasma which is then extracted out as a stream or as a column of a pure highly energetic plasma through a nozzle or through a very fine point, and which result into a high temperature and very high pressure of the plasma, and that plasma is then used in potential applications in microelectronics industry, welding industry, and as well as thin film industry. So now dear student, let's make the topic very simple. Basically the student, plasma arc igniter system, what do you think, what are the possible parts of plasma arc igniter system? So I will briefly explain that what are the key basic parts of plasma arc igniter system by a schematic diagram. Please note that, dear student, the plasma arc igniter system consists of a cathode. Okay, so the cathode in plasma arc igniter system is connected with negative terminal of direct current potential source. Okay, so this cathode is basically in plasma arc igniting system is connected with negative potential of direct current potential source. Dear student, what do you think, we need a direct current potential source in plasma arc igniter system. Basically, why we don't use AC potential source in plasma arc igniter system? The reason of using a direct current potential source is quite simple, because direct current potential source or direct current batteries are very efficient. Okay, they give full potential to the electrode material. Okay, now the plasma arc igniter system consists of nozzle. Okay, the nozzle has a very small portion, and that portion is known as orifice of the nozzle, or it is basically a small hole, or it is a thin part of the nozzle. So please note that this small hole or this small orifice in plasma arc igniter system is very important, because the small stream of fine stream of the plasma will when it will pass to this small orifice, this will result into a very high temperature because of the very high pressure. Okay, so and in this case, so due to this, basically the plasma at the orifice, which is basically extracted from at the point of the orifice, is further used in technological application. Okay, so the cathodic, so the plasma arc igniter consists of a cathode which is connected to a negative terminal of the direct potential source, and the cathode is surrounded with a little bit space by a plasma arc igniter nozzle. Okay, the nozzle please note that the nozzle of the plasma arc igniter is connected with positive terminal of the direct current potential source. So the nozzle acts as anode in plasma arc igniter, whereas the cathode is present inside the nozzle at a small distance, and it acts as a negative potential source. Okay, dear student, please note that the temperature of the system usually in plasma arc igniter become too much. So in order to decrease the temperature, cooling setup is used across the plasma arc igniting system. Usually the cooling setup is composed of water, but there are also different types of secondary gases which may be used to cool the electrode of the plasma arc igniters. These secondary gases may include nitrogen, helium, etc. However, most commonly the cooling gases, or most commonly the cooling material used, or the cooling channels used in plasma arc igniting systems, are based on water. Okay, so now, dear student, the nozzle of plasma arc igniter is connected with positive terminal of the direct current potential source, whereas the cathode is connected with negative terminal of the potential source. The potential between the cathode and the anode, which is basically a nozzle of the plasma arc igniter, is too much. Usually in plasma arc igniter system, the potential operate in thousands of volts. Okay, so when the potential between the electrode and cathode is too much due to a difference of potential between the cathode and anode, they will cause a spark, or they will cause an arc at the tip of the cathode. So dear student, please note that this arc has a very high temperature and it has a very high current. So when an external gas is incorporated in plasma arc system like this. So these arrows represent an external gas which we want to ionize in plasma arc igniter when it is incorporated inside the plasma arc igniter systems. Okay, the arc, which has a very high potential at cathode, will result into the ionization of the incorporated gas. Okay, so when the external gas interact with the arc, which is operating at very high temperature, thousands degree of centigrades. Okay, so when it interacted, they result into a formation of plasma inside the plasma arc igniting system. Okay, so the plasma is formed between the cathode and anode, or between the cathode and nozzle of the plasma arc igniting system. So this plasma has a very high temperature and as well as pressure. When the plasma reach to the nozzle, to the tip of the nozzle, which has a very small orifice, the orifice is usually is in few millimeter. So when they pass through this orifice, the temperature and as well as the pressure of plasma due to a narrow region or due to a thin region will further increase. Okay, so this means that when the plasma pass through this orifice, the temperature of the stream of the plasma, or the temperature of the directed plasma, will reach up to thousands degrees of centigrade. Dear student, please note that usually the temperature of the plasma when it passes through the orifice reach around 10,000 degrees centigrade to 30,000 degrees centigrade. Okay, so the stream of the plasma will basically pass through a small orifice of the plasma arc igniting system. So in this way, basically we produce a plasma from the plasma arc igniting system, and this plasma has a very high temperature. So dear student, please note that in this way, basically dear student, please note that this stream of the plasma, which has a very high temperature and as well as a pressure, will further be used in welding, which is known as plasma arc welding, and it may be used in different types of microelectronics application, including cathodic arc deposition. So now let's explain that how this stream of the plasma may be used in cathodic arc deposition systems. Dear student, please note that the cathodic arc deposition system, as I have previously discussed, that it has an electrode, which it has a cathode which acts as a precursor material. Usually the material from the cathode is extracted and it is transported onto the surface of the substrate, and then it is deposited onto the surface of the substrate in cathodic arc deposition systems. So the student, the cathode usually used is metallic in cathodic arc deposition systems. So now, as I have previously discussed, the temperature of the stream of the plasma is in thousands of degrees centigrade. So basically you can melt refractory metals, you can melt any type of metals from which cathode material is made. So this makes cathodic arc deposition process very diverse because of this plasma arc igniter. So when the stream of the plasma arc from the plasma arc igniter interact with the surface of the cathode material in cathodic arc deposition system, they will result into a melt of the very small region of the cathode in cathodic or deposition system. This small region or small part of the cathode which is melted and converted into a vapor of plasma is known as cathode spot. So, in cathodic arc deposition process, highly energetic plasma from the plasma arc igniter when interact with the surface of the cathode material, they will result into a small region of cathode material to be evaporated and converted into a plasma, which is a composition of ions, electron, and as well as neutrals. Okay, so now interesting point here to notice is that the cathodic arc system, when a small region of the cathode is converted into a cathodic spot, that spot, due to a high energy which is basically given by the arc igniter, they will result into the movement of the cathodic spot somewhere around the surface of the cathode material. Students, please note that the movement of the cathode spot on the surface of the cathode material will cause the non-uniform evaporation or non-uniform erosion of the cathode material. So if you know that the energy of the cathode spot, energy of the plasma is maximum here, and this plasma spot or cathodic spot which is produced will have maximum energy at the center. However, when the spots move across, they will cause a non-uniform evaporation or non-uniform formation of plasma throughout the surface of the cathode material. So and secondly, this non-uniformity, apart from the non-uniformity of the evaporation of the surface of the cathode material, there is a possibility of the spot to get out from the surface of the cathode, and which will result into a non-uniform deposition of our thin film from the cathodic arc deposition process. So in order to get a uniform deposition of the thin film from cathodic arc deposition process, and in order to confine our cathode spot in cathodic arc deposition system on the cathode, we need a special type of arrangement. One type of arrangement is known as passive arrangement. So basically, in passive arrangement, a passive material like boron nitrides, the rings, they are used at the edges of the cathode. So their arrangement is very special in instrument. Okay, so what these boron nitride rings do, dear student, please note that boron nitride will confine the cathode spot onto the surface of the cathode. They will never allow the cathode spot to get out of the surface of the cathode. Another type of very special arrangement which is used to confine the cathode spot onto the surface of the cathode is known as magnetic confinement of the cathode spot. So magnetic field or magnetic coil in cathodic arc deposition system is used in a special way. So they basically, their magnetic field or magnetic pole or magnetic field of line will interact with the cathode spot and with the magnetic field of lines, because since you know that the cathode spot, which is basically a plasma, it has a mixture of protons, it has a mixture of ions, electrons and neutrals. So the magnetic field of line will interact electromagnetically with the electrons, protons, and neutrals and ions. So due to electromagnetic component or due to electromagnetic field in a specific direction, they will basically confine the plasma up to a specific region onto the surface of the substrate or onto the surface of the cathode in cathodic or deposition system. So, dear student, passive confinement and as well as magnetic confinement is used in cathodic or deposition system in order to confine the cathode spot onto the surface of the cathode. So let's conclude the plasma arc igniter system. Okay, basically plasma arc igniter system consists of cathode and as well as electrode, as well as anode. The anode nozzle of the plasma arc igniter acts as a anode. The cathode and anode of the plasma arc igniter are connected with highly potential direct current source. Okay, the cooling system, usually a water cooling lines are incorporated across the plasma arc igniter system to decrease the temperature of the electrodes. Okay, or they are also used to decrease the temperature of the cathodic systems. The gases are fed in between the cathode and anode of the plasma arc igniter from the outside. So when the high potential is applied between the cathode and anode, they will result into a very high temperature spark at tip of the cathode. So when the gases are incorporated between the cathode and anode of the plasma arc igniter, the high temperature of the arc will result into a ionization of the introduced gas, and the introduced gas will be converted into a plasma. This plasma and plasma arc igniting system is directed from a small orifice onto the surface of the workpiece. Okay, so in this way, basically the stream of the plasma having a very high energy and as well as temperature, that stream from the plasma arc igniter is used in cathodic arc deposition systems and as well as plasma arc welding.